So here I'm asked to write down all of the prime numbers between 20 and 30. So if I'm looking for the prime numbers here, I'm just going to make this easier to visualise by writing out the numbers between 20 and 30 so that I can then cross off all of the ones that aren't prime and have other factors other than 1 in themselves. So the numbers between 20 and 30 go from 21 to 29. And initially here, I'm going to start by crossing off any that have obvious other factors apart from 1 in themselves. So I can take out all of the even numbers, for example, because they all have a factor of 2, so they cannot be prime. So 22, 4, 6 and 8, they're all even, so they have a factor of 2. Now similarly here, if we're working with numbers, consecutive numbers between 20 and 30, I know that there's going to be multiples of 3 within here. Now 21 is going to be 7 multiplied by 3, so I can cross this one off as it has a factor of 3 and a factor of 7, but either way we know that it's not prime. Similarly, counting up again, 24 is also a multiple of 3, but we've already crossed that off as a multiple of 2, so we know that that's not prime anyway. And going up again, 27 is also a multiple of 3, so we can cross that one off as well. Now looking at the numbers we have left, we have 23, 25 and 29. Now 25 is going to have a factor of 5, it ends in a 5, so I can cross that one out as well because it's got a factor of 5, so it isn't going to be prime. Now we're left with both 23 and 29, and both of these numbers are going to be prime as they have no other factors other than 1 and themselves, so I can write these down as the prime numbers here. So you may have instantly looked at this and seen that 23 and 29 are going to be the only primes. Sometimes you might be more familiar with the prime numbers, but if not, we can just look for factors and check as to whether these numbers have factors other than 1 of themselves, so they won't be prime. Now here we're told that Catherine says the number 2 is the only even prime number. And we're asked whether Catherine is right, and we must give a reason for our answer. So this question's just worth 1 mark, so we're just going to be looking to state whether she's right and then give a brief reason as to why we think this. So working with the number 2, firstly, number 2 is prime and it's even. And it's the smallest even number as well, just starting to think about this. And then if we look at the fact that it's the only even prime number. Now, a property of even numbers are all multiples of 2. That's their main property. Every even number is a multiple of 2. Now, if every other even number is going to be a multiple of 2, every even number is going to have 2 as a factor of it. Now, for a number to be prime, it must have only factors of 1 in itself. So if it's even, it must also have this factor of 2 and therefore cannot be prime. So in this instance, yes, Catherine is right, and that's going to be because all of the other even numbers, so all even numbers greater than 2, have the number 2 as a factor. So cannot be prime themselves. However, 2 has factors of 1 and 2, so 1 in itself, so therefore is prime.